Hello everyone, I'm Malini Bandaru, an open source cloud architect at Intel. Today we're going to talk about AI pipelines, how to make them scalable, confidential, and sustainable. Scalability is to meet dynamic load and cost control. Security is to protect the data, which is often sensitive, private, proprietary, and regulated, and the models themselves are valuable. Sustainability is to protect our planet and curb climate change. How do we address these challenges? For scalability, we can use Kubernetes' pod autoscaling. That's horizontal and vertical pod autoscaling. And the project KEDA. KEDA, which stands for Kubernetes Event-Driven Autoscaling, allows us to monitor multiple sources and react per policy. For security, we already have Kubernetes' RBAC, Kyverno, and several best practices. But in addition, we can bring in confidential computing. Confidential compute is hardware-supported encrypted memory, integrity protection, and protection from access by even privileged processes. It also supports attestation. Last but not least, with sustainability, Project Kepler can help us. It allows us visibility into our energy consumption and its carbon footprint. We can use special purpose instructions and hardware and software that leverages that hardware to achieve performance that is energy efficient. We can use Intel's AMX for matrix multiplications that's fast and energy efficient. We can use AVX 512, Intel's Q80 for crypto and compression. Let's take a look at an AI pipeline. We are going to illustrate this in the context of video processing. It's a scenario that's common in retail and surveillance. We do object identification in video streams. Our AI pipeline is composed of 4 microservices with a feedback loop. On the extreme left, you see our cameras. They're collecting the video streams and they will pump that into the microservice to the extreme left next to it, the media transcoding gateway. From there, they get queued to be processed, each of the frames in that video. After some initial processing, they are sent off into more purpose-driven inference engines. Maybe it's a face app. Maybe it's a retail app where we're going to check for bananas and flour and milk and eggs and things like that. And finally, our microservices will update a dashboard. In this example here, we've illustrated face detection. With that, let's get to our demo. I'm delighted to show you our demo. Let's take a closer look at this pane. At the very top, we have our inference engine running in Intel TDX. That's our confidential enclave. I want to point out a few things here. It's handling an input frames per second of 25, and it's doing a perfect job. It's handling all those 25 frames without any drop. These RTMRs here, they are measurement registers. They have captured the kernel measurement, the BIOS measurement, any other firmware that's running. So these are useful to indicate and attest that this is a valid, genuine Intel enclave that has exactly the code you want running. The instances below, all 4 of them, are normal containerized inference engines, so they are not confidential, and there are 4 of them here. So we have, in essence, 5 inference engines active. What else do these others capture? They capture the frames that are coming into them and the frames that they're able to handle. The bars in the middle over here indicate the latency to handle an inference and to update the dashboard. The very middle column is indicating the number of frames that are coming in, handled, and dropped type of thing. Let's move over to the right-hand side. At the very top, we're indicating the number of frames that we're handling and how well we're doing with that. The bar in the middle is handling the number of instances we have of the inference engine. When another camera comes in or when the number of frames that we're dropping are high, we launch another instance. This is all part of the Kubernetes pod autoscaling, part of KEDA giving feedback in its feedback loop. I want to point out yet another piece, and this is the scalability brings us energy savings, but also using special purpose hardware like Intel's AMX over here. When you use it, you use less power. And as part of this demo, you'll notice when I run it that there are moments when the energy consumption is higher, when we have more instances of the inference engine, and then when it falls down because we are using fewer instances of the inference engine. So let me run the video, and around the 10-second mark, you will notice that we have another camera feed coming in. There we go. Stop us here. Look how we have another instance just to cope with the extra, frames coming in from the other camera. You'll also notice that as part of this, the number of instances has increased, but also our power consumption has increased. And I shall fast forward our video a little to around the 1 minute mark, where you'll see number of frames coming in has decreased, and lo and behold, therefore, we dropped the number of instances, and also our power consumption carbon footprint has decreased. Thank you. Please give our AI pipeline a try. It's up on GitHub. I want to point out another thing. You could use confidential computing in a cloud-native environment in one of many ways. You could have a confidential virtual machine, or you might have a confidential Kubernetes cluster, or a confidential container. Regardless of your way of consuming confidentiality, we need primitives. Primitives for getting the event log, primitives for attesting your workload. And that's where our confidential cloud-native primitives comes in. And that's used in our AI pipeline. Please give that a look too and explore it, give us feedback, and perhaps you'll contribute too. Come and enjoy this journey with making our AI efforts planet-friendly. Thank you.